Is that good?
You want to test? Do you have sound or? You probably have to switch your sound. Yeah.
Should be this one.
The other one. The HDMI.
But I want from this one, right?
Okay,
yeah,
that doesn't work.
be.
That doesn't work. So when we have
I think whenever
HDMI,
you use HDMI, it
let's
doesn't.
jack out.
Okay.
Oh, it's from here, from this side, that it doesn't work.
It's a volume. I have to control volume either there or.
I think it doesn't even.
Yeah, doesn't let me.
Yeah.
Yeah.
But
Do
this is
you have a possibility of using VGA or from your adapter doesn't go to VGA? No.
I mean, you can switch to.
Yeah, that one, I guess. Yeah.
Does it then sound?
Yeah, it's just not so loud.
Oh yeah. Oh yeah, it's really quiet. Yeah.
For some reason.
We all can.
Volume there.
It's already maximum.
Yeah, but it was like that for everyone.
Yeah. Does this mean HDMI to VGA? Is there a chance that? But the cable's not long.
Yeah.
Otherwise, we could actually use this.
It's not as loud, yeah.
No.
If you can put your computer here, we can maybe set this up. But it's, I don't know if it's too.
Or this one. Yeah.
Or actually, there's.
Like this. Or?
Yeah. So the thing is that this is probably. I think it doesn't need power. So. Is there a way to
We can search how this works.
maybe we can.
Stop soon.
Yeah.
Yeah, let's do that.
Yeah, a year ago.
Okay. Yeah. No, yeah.
All right. Is it okay that you have
Yeah. Cool. Right, leave it.
I think you can leave it, yeah, because we're using VGA now. Or
Yeah.
Verlängerungskabel wäre eigentlich.
All right, so we will start the poster craze, and I hope that everyone who actually made a slide is actually here. So I'm just going to quickly go through the slides so that you know who should come to the stage and in what order.
Yeah, maybe you can all wait in line.
Yeah.
It's really going to be quite.
So you just have 1 minute, so you should all line up. So this is the first, second, third, fourth, fifth, sixth.
I think now it's already.
7, 8, 9. Yeah, that's it. So we will do it in that order, and you have about 1 minute. And then, if you go beyond that, we will just play the triangle.
Until you stop.
All right. So, are you ready?
Yeah.
All right. So, and here we go.
Hello, I'm here to talk about NX Physics UI. We've taken physics engines for the web and combined it with synthesizing, or synthesis, and we're trying to make Rube Goldberg devices, basically. So you can map any kind of weird sounds to crazy physics models and build these really nice nuanced instruments and have a lot of fun exploring crazy new ways to synthesize in the web. That's about it. Go check out the demo.
Okay, number 2.
Hi, I'm a scientist doing signal processing mostly. And to test my algorithms and theses, I have to use scientific hearing experiments. And of course, I would like to do these hearing experiments using web technologies. And some of us are already doing this. But when we translate our scientific code bases to JavaScript, we're facing a few challenges. And these I would like to discuss with you later in the poster session.
So I'm Stéphane Netz from Gram in Lyon, France. So I'm presenting this poster, recent development we did to target WebAssembly and web audio nodes from the Faust language. Faust is a domain-specific language for sound processing and synthesis. And I will show in this poster how we can directly generate WebAssembly and so deploy the Faust compilation chain completely in the web. So having the compiler itself also compile to WebAssembly using mscripten.
Hi everyone, I'm Nick. I'm a PhD student at Birmingham City University. And we're going to give you a demo of our new intelligent digital audio workstation that we built in the browser. Obviously, I think we've also got some Soundtrap here as well today. But our one, we're doing a lot of semantic interactions and intelligent functions built into the browser to see basically how people react to them, whether it actually helps them, hinders them, or what we do. So we've got a lot of interesting stuff that we've uncovered. So you can come to the demo, and hopefully you can also try the browser for us and give me even more information. Thanks.
Hi everyone, I'm Benjamin from Corona Audio, and today I will be presenting the web implementation of one of our technologies, Arcade, which is a 3D audio codec that is able to embed most 3D audio format, be it HOA, multi-channel, into a stereo carrier that can even be further compressed using most stereo channel compressors such as AAC or Opus or MP3, and that can be decoded back to all audio format, including HOA, binaural, even head track binaural. So today I will be presenting the challenges we faced during that implementation, and I will be giving live demo, including a live presentation of the sound field that is decoded. Thank you.
Hey, I'm Matt, and I have been building it's kind of a DAW, but it's more of a, it's kind of like a very elaborate Max patch, but I built it entirely in web audio and with Electron. So if you want to come and see me play some live techno with a big TV, and you can try it out yourself. And I'm giving a talk later this afternoon talking about some of the challenges I've encountered building something that is playing thousands of audio nodes at a time, creating entire tracks. I mean not tracks. What do you call those things? Like the music things, songs. Yeah, songs. With web audio, we are synthesizing every single instrument, or at least processing heavily. And I'm going to be giving a performance on Wednesday night, actually playing it, so you can see what it's like. Yeah.
Hello, I'm Raimund Vogtenhuber from Zurich, ICST. I will present Cloud Speakers, a mobile performance network. Cloud Speakers are mobile speakers connected to Raspberry Pis, which are equipped with low latency PC audio card. They are connected to a Wi-Fi network and can be addressed with a super-collider language. And it's a scalable network, and it can be used for artistic projects and with mobile phones, also with a web server.
Hello, I'm Adam from Goldsmiths, and this is some demos made with Mike and Francisco here. This is part of the Rapid Mix project, which is developing amongst other things, machine learning toolkit for artists and musicians. And we've got it running in the browser in CodeCircle, which is a browser-based IDE, and using the RapidLib library, which is allowing us to prototype gestural musical instruments, NIME-type instruments in the browser. So controlling amen break slicers with leap motion control sensors. And we think it's a really interesting domain to be doing machine learning. People don't often think machine learning, that'd be great for cutting up amen breaks. But in music, you have, lots of parameters that you want to be able to control in an intuitive way, in an embodied way, and machine learning lets people, or interactive machine learning in particular, you really quickly prototype how different gestures can give you a sort of very organic, embodied control of musical instruments. So come down and try it out and make some noise.
Hello, I'm Frederic Font. I'm a researcher at the Music Technology Group in Barcelona. And here I'm presenting this web app called Free Sound Explorer, which is an application to explore free sound and make music at the same time. Free Sound, as I guess most of you will know, it's a collaborative database of sounds licensed under Creative Commons licenses, and there are more than 300,000 now. And the idea is that, well, there is a huge creative potential behind that, and there are many ways in which it could be explored. And here what we try to do, well, me and my colleague, try to build these maps in which we represent the sounds in response to a query, and you can create playlists of sounds, you can, that then you can synchronize to a metronome, you can record, you can use some MIDI input. So it was a bit of learning technologies and playing around to see how can you make music in a super fast way using free sound. So the code is open source, and the idea is that if anyone likes it and wants to contribute, would be most welcome. So come and see the demo, and hope you like it.
Yeah, that's it. So thanks everyone. Yeah.
Oh, here.
Yeah.
Is it turned on?
No. Yeah. I think. Oh yeah. So we'll have to turn it on. Should we play that? Sure. Yeah. I think Fred can talk first, so you can take that. That's great. Thank you. Resolution. Yeah. Is that right? Okay, now. Do the pages need to be refreshed? These ones? Yes. Should be okay.
Yeah, because you can slide and do that.
Good. You have the app then. Let's see. Right, yeah.
Is it? Yes.
Yeah.
Just waiting for other contact.
So it's like USB-C, HDMI, D-pad.
Okay, I've got the green light. Okay, so I'm very happy to present the Soundtrap people. I spent a lot of time on Soundtrap trying to guess how you did this, guys. And you were, before my amplifier, you had a guitar amplifier and guitar effects. So I tried all of them very accurately. So I'm happy to give you the mic and see your presentation.
Thanks a lot. Thank you. My name is Frederick.
Hi, and I'm Andrew.
And we're developers at Soundtrap. So what is Soundtrap? Well, Soundtrap is an online music studio, or DAW, with the key features being that it's collaborative and cross-platform, so web, iOS, Android, and with a focus on being easy to use. It's used in both consumer and educational context in schools, and right now we have around 1.5 million registered users. And we'll start with a demo so you get a sense of it, how it works. Yeah, so to anyone familiar with a DAW, this will be very familiar. We have a song here with a bunch of different tracks. There's some MIDI tracks, some audio tracks, and if we play it, it sounds like this. And we have the drums over here. Some acoustic guitar here. It sounds okay, but I think something's missing, right? So if we go up here, we have the loops library. We're thousands of different loops that you can add to your project. And you can search for them by tags. You can do like, oh, maybe we need some drums, like rock drums maybe, or no, no, no. So if you don't find what you're looking for here, then you can always invite someone to collaborate with, and maybe they can provide some more creative juice to this project. So I'm going to try that right now, try to invite Andrew here, see if we can get some help from him. So if we, yeah. Invite him. This.
Okay, so I get an invite, and I can do this either on phone or on the web or on whatever other device. I got a push notification to my phone right now with the project, so I'm just going to accept Frederick's invitation here and then go into the studio. And once I'm in the studio, I'm going to see interface on the phone. I can show anyone later if they want, but it's very similar to what he sees. And so anything that I add here, any MIDI tracks that I add, record vocals, import other audio, it can then be synced over to the main project that we're sharing, and we can collaborate on it in real time. So I think I should be available there.
We see Andrew is online now. He's in the studio, so I can chat with him over here.
I can chat back.
Or I can do a video call and call him.
Yeah, yeah. And then I'll get a little pop-up here, and my face should at some point show up there. Yep. I don't mute that. Yeah, so hey, here, I'm ready to collab.
Yeah, could you give me some help on this song? I think it needs something more.
So on the phone here, I can just go over into the project, and I think we're missing a little bit of vocals. So I'm going to open that up, maybe crank up the volume on the vocals and sync that, and that'll head over to Frederick.
Now I see here that someone has made changes. Probably it's Andrew who's made some changes, and I can sync them in. So thank you for that, and now we'll see or hear what this sounds like now. Much better.
That's it. Sounds a little better.
Yeah. So that's a short demo. You get a little feel for what you can do with Soundtrap. So I'll hand over to Andrew now for some more.
So I'm going to focus a little bit more on the implementation side of stuff. So how do we do some of the things we do? And I'm focusing mostly right now on kind of how we do this functionality where we can have it working in the web and on smaller devices like Android phones. So we work across all major browsers on high-end and low-end devices. In order to do that, we need some ability to control the CPU and memory use. We also want the ability, wherever we can, to do glitch-free monitoring, which was very similar to what the guitar amp guys this morning were talking about. So I'm going to just focus on each of these sections a little bit independently. So first, in terms of CPU, there's a graph on the right showing basically the performance of a few key nodes across a wide range of different platforms and browsers. So this is kind of what we're dealing with, and we have to keep in mind these different numbers. So right now, when somebody connects to Soundtrap, we're going to do some checks. We're going to run a few nodes through an offline audio context to get an idea of what their platform can support, and then using that in addition to some other things like the hardware concurrency, take a guess at how heavy we can make the web audio graph. So for lower end devices, we're going to maybe not use convolver nodes, no reverb. On higher end devices, maybe we're going to use a lot of oversampling in our wave shaper nodes to get a really high quality output. In addition to that, we have a few other things we're doing, like freezing of finished tracks. So on a low end device, we might burn a track down just to its audio and not run the whole graph. So if you're doing a multi-track thing, you probably set one track, leave it, and then you're working on another, and we might freeze the ones you're not working with. And we also do a bit of server-side processing where possible. So for the final output, we do that on the server so that it can be as high quality as possible. Memory is another aspect here. I'm only going to touch on one aspect, and that's around an example with podcasts. We have a lot of users who record maybe hour-long podcasts, and right now this needs to be held in memory. So we don't have a lot of information about the state of memory on the system either because we're working in the browser. So we can end up with out-of-memory errors, which can then result in data loss, which is a bit unfortunate. So audio data streaming is something we'd love. And working towards that, we've written our own kind of custom codec using libvorbis, Emscripten, and a web worker. On the right, there's a really quick graph showing kind of the peak and like runtime memory use. This was done in Chrome of an hour-long OGG file, either decoding the whole thing with the code audio data or doing it partially using our codec. And there's quite a big difference there. Last one is audio latency. I know you guys were talking with this. We have been working with the Chromium project for the last 6 months or so. We contributed code to add the latency hint support into Chromium several months ago, and since then, we've added some additional code to drop the buffer sizes even further, so to allow using the latency hint to request buffer sizes below kind of the initial defaults. These are the latencies across a wide range of, again, devices and browsers. I know you were mentioning that this morning in your talk as well. The lowest right now is on the far left, and it's with Chrome 62 on OS X, where we've gotten it actually below 20 milliseconds now. So progress being made, but there's still more to be done here. And I'm not going to go through all these points, but anyone who's interested in any of this stuff, one of our biggest reasons for being here at the conference is to meet others who are working on this, see where we have room for collaboration, and do some data sharing around what our experiences are in the browsers. So, yep, back to Frederick.
Yep. I'm going to quickly go through some more experimental things, looking ahead in the future, things we've been looking into. One of them is what we call low latency jamming. Some of it we heard this morning. So we've been doing some measurements and some experiments with this using web audio and in combination with WebRTC. So sending audio between browsers. So the first method we tried was kind of the regular way in which you would use WebRTC with web audio. You create a media stream destination, and then you send your web audio output through that. And the second method was using a script processor node. And then we extract audio buffers and then send those with data channel, WebRTC data channel. And then the third one we tried was sending MIDI events over the data channel. So you would send just an object containing the velocity and the note that was played. It's not really audio samples. And after a lot of testing back and forth, we got to these results as the latencies. And this is latencies from when the sound is generated on the sender to when it's recognized as a peak in amplitude in an analyzer node on the receiver. And this was on like a recent MacBook, sort of like this one, and in Chrome, so it's kind of the best possible conditions. So we tried to see what kind of latencies can we get down to. So as we expected, media stream was the slowest because it's kind of optimized for voice, and it has all these, like packet loss stuff, so it doesn't chop voices and stuff. And then data channel, sending audio over data channel was second fastest, but it suffers some consequences, like you can't resize the browser because the script processor node is kind of on the same thread or something. So yeah. And then media events, sending those is the fastest, but it obviously has some musical limitations. You can't send like mic output with that. And then the second thing we've been looking into is AI music generation, specifically using the Google Magenta project by the Google Brain team. Magenta is about using machine learning to generate music. And we have a small REST wrapper around their Python API that we can use to import media notes into the Soundtrap Studio. And just last, I'll show a little example of what that can sound like. Some AI generated music. So this project was entirely generated by this AI, and let's listen to it. So this is, yeah. There's like a synth and some drums, and both generated by this AI. Yeah, it's pretty catchy. So, yeah, that's almost all. Whoops. Yeah, so, and we're hiring later this year, so please apply, and thanks for listening, and yeah, that's it for us.
Any questions?
Hi. When we were talking about for different devices, kind of scaling down, kind of what they're doing, are you just, is that client side, or are you using offline?
I mean, it's just clients choosing how to build the web audio graph, basically, omitting certain nodes, using certain parameters on other nodes to make it kind of lighter on the CPU, but it's all done client side.
Okay, so where the offline, are you just presuming the offline context is there, or are you just building that?
Do you mean, because we're using the offline context to do some of the checking around what that device can handle. Do you mean like for places where it doesn't exist?
Yeah.
Right now we are assuming it exists.
Okay.
Yeah.
Nice.
I mean, are there many implementations where it's not out there right now?
No, I mean, sometimes posts aren't really iPads.
So the iPad is a bit of a hybrid, actually. There was some stuff going on in there. We have some native code on the iOS app as well. So we're doing a bit of shimming on the iOS app. So it's a bit of a special case there.
Could you talk a little bit more about the huge user base and who they are and how it's being used? Because that's brilliant take-up, obviously.
Sure. I think right now the predominant, like the biggest chunk of our user base is in the educational context. So it's a lot of schools in the US, in Sweden, Canada, a few other spots where they're using it in music classes and other types of classes. They're using it for podcasts, they're using it for music. We also have, I don't know the exact numbers between the consumer and the educational. Yeah, we have decent sizes for both, and we have a big chunk in the educational system right now.
Thank you. Really impressive. How do you deal with conflicts which can occur between users on one track or samples?
In terms of syncing, so we have an algorithm. Not all the information about how it works is totally out there. There's no reason it couldn't be, but we resolve conflicts. We don't do anything about saying, oh, somebody else has changed this track. It's basically first in wins, or last in wins. So if I change something and he changes something, his change will overwrite mine. Okay. That has worked fine to now, but I mean, that whole algorithm is completely configurable and changeable based on whatever users kind of need.
Can't we lock something so that nobody can change?
Not today, but that's absolutely something we've discussed, and no reason it won't be coming.
Okay, thank you.
Time for another question? Yeah. Okay, I've got one about the latency. I found traces of Soundtrap, posts by people from Soundtrap on the different Stack Overflow forums and bug reports, and I saw that you used a table. You check the configuration, and then you assume that this configuration has such a latency, and so you compensate. But how do you do this on Windows machines? I mean, if I want to record my guitar, I need a direct monitoring, because otherwise I cannot.
It's like you said, there's no direct monitoring on Windows right now. The latencies, what we measured, are somewhere between 70 and 100 milliseconds on Windows. Yeah. So we don't do.
Yeah, okay, so you assume the user has the direct monitoring, and then you just shift the.
That's exactly it.
The track.
We allow them to record, and we're just using latency to do the track shifting. So they line up. Yeah.
Okay. Okay. So maybe we go to the next presentation by people from the Queen Mary University, and they will talk about audio feature extraction in browser and mobile application. Do you need the micro? No.
Cool. So, hi, I'm Lucas. I'm going to talk to you about audio feature extraction in browser mobile applications. This is work I did here at the Centre for Digital Music along with Chris Canham. So, just to get started with a bit of background, we have quite some time here at C4DM developed this desktop application called Sonic Visualizer, which is sort of a general purpose application for audio analysis. You can open some music, perform various different analysis tasks, and visualize the results. And you can, as a user, install further methods for feature extraction. And as a developer, you can write these in a plugin format called VAMP in C++. And there's a bunch of useful ones available. So out of our lab, there's a plugin called Chordino, which is good at labeling chords, particularly in rock songs. There's an algorithm called PIN, which is for monophonic pitch and note tracking, so for transcribing a singing recording or something. There's the Queen Mary VAMP plugin library, which itself contains things for beat tracking, key and tempo detection, song segmentation, etc. And there's many more, not just out of Queen Mary, but other universities, organizations, and individuals. So what's that got to do with the browser? We had this kind of overarching goal that we want to develop cross-platform apps for audio analysis and write them in JavaScript, not just for the browser, but to make cross-platform mobile apps using something like React Native or Ionic. So I'm going to talk about a set of tools and opinions for doing audio feature extraction in these environments. making use of existing work, especially VAMP plugins. We don't want to have to rewrite these algorithms in JavaScript. So we're going to bring them to the browser using existing tools for doing that kind of thing. So we've been working on a number of things that center around a protocol that we've defined for driving feature extractors called Piper. We provide some tools for wrapping existing C++ VAMP plugins to something that conforms to this protocol and then compile that to JavaScript within scripting. There's a library called Piper.js, which is for building clients and servers that do this kind of stuff and to give you a set of data types and operations on data types that make that easier for you to do. And then we pull this together in an app called Ugly Duckling, which kind of showcases what we can do with that. So what's this protocol? It's a set of structures and verbs for requesting feature extraction. So it breaks down the life cycle of doing a feature extraction process into 5 distinct operations. I'm not going to go through them all now. You can refer to the submission and the docs. But basically, the first thing you'd do is send a list request. You'd find out what extractors you can interact with. And then basically, you end up driving them block by block. And this is as it is, so we can interoperate with existing plugin formats. And as I've alluded to, this is a client-server model, which is a pretty useful abstraction for this kind of stuff, because it means we can afford you the ability to drive remote feature extractors, but more likely it corresponds to crossing a language or a process boundary in a single application. So practically, in a web app, you're going to be sending messages over a web worker, or perhaps in React Native, you're crossing to a native bridge to some actual native audio code, which is doing this abstraction. And we formalize these structures with a JSON and cap and proto schema, so JSON being convenient for the web, and cap and proto being a binary serialization format, which is more compact. So this low level, this is an example here of the a JSON configuration request, giving it some information about the framing of the audio, configuring a particular plugin with some parameters it exposes. And then in Piper.js land, you're going to abstract these things behind an interface like this. So there might be well, in Piper.js, there's a web worker service, which takes care of actually doing the messaging. And you have these data types of a list request in your code, and eventually you get back a response. And you might have a React Native service or something like that, which actually handles crossing the boundary. And we're working on a higher level stateless API, which is more, here's all the audio, give me the features. And there's various clients in Piper.js which approximate this already. So, oh, brilliant. GitHub Pages is temporarily down for maintenance. Oh, it's bad, it's bad. So embedded on the right here in an iframe is an app live on my GitHub Pages, which pulls some of this together. It's written in Angular 4 and relies heavily on Urkam's Waves UI for actually doing any of the rendering of the features we extract. And it comes bundled with a set of basic extractors, which happen to be the VAMP example plugins compiled with mscripting, but they could reasonably be written in JavaScript. So we play an audio file here with some weird clicky beats. So we might want to extract something to get some information. So I'm looking for, it's probably pretty small, but I'm looking for a spectrogram. There's something here called simple power spectrum. I extract this, and we see it's a little contrived example where this is the workload. So something else this can do is dynamically load in new modules. So let's do something a bit more musical. This is pulling down some more bundles from the internet, and when it's done, it populates the list. So if I open someone singing, I referred earlier to that Pin plugin for pitch transcription. So if I scroll down here, there's an output called smooth pitch track. So this is all happening in a worker. I can still interact with the app whilst it's extracting this. And when it's done, I get this pitch track where I can read off that this note's at 155 hertz, 176 hertz. You can map these to MIDI frequencies or whatever. And this is done using a client in Piper.js called the streaming client, which is how we kind of power those progress bars and stuff. So let's look at quickly trying to make something a little bit similar. I've got loaded up a text editor, online text editor here called Stack Blitz, and I've set up kind of a skeleton project on the right here, which has a component that's going to function as a piano roll when we give it some MIDI-style note information. And it's got a synth in the background using Tone.js, which is going to play the notes. And when I load in a file, eventually we're going to end up calling this function here called transcribe, which we're going to fill out. And at the top, I'm pulling in from NPM. The resolution is terrible. That PN plugin, which is use some tools from Piper.js to wrap it to run in the worker. But from the point of view of our application here, we don't really need to know that. It's abstracted behind that service interface. So I just instantiate it here, which spawns the web worker. And the first thing we need to do is create a Piper client. So in TypeScript, no, well, this is written in TypeScript. But in Piper.js, there's something called a one-shot extraction client, which it hides those individual lifecycle requests. And all we're interested in is it takes a service. We can call list on this thing, which we're going to do in a minute to find out what it can do for us. So we're using ES2017 syntax here. I'm in an async function, so I can just await the result of this asynchronous list request on the client. So I'm sending it an empty list request, which means tell me everything you can do. You can actually filter a list request. And I've got some stuff set up on the right-hand side where we can inspect this response. So I'm just going to forward through the response. When I load a file, it's going to trigger this through. And down here, it still doesn't do anything. But we're going to look at this response here. So there's an array of 3 elements here, which means there's 3 extractors. And they all have a unique key. So this one's pin, local candidate, pin. I'm going to skip right to the one that I know I want, which has this key here of pin. So we're going to take a note of that. In a real application, you'd use this to populate a menu or something, but we're doing something specific where we're going to hard code these. And there's various outputs here. So there's something called estimated fundamental frequency. We want this one down here, derived fixed pitch notes with an ID of notes. So we also need to remember that. So now, instead of calling list, we're going to call process. And we need the audio in a specific structure. We're getting some audio passed into this function, but we need to just map it slightly to what this needs. So this is an array of samples, and we need to give it some information about how it's encoded. So we give it the sample rate, which we can read off of here. And we give it the number of channels. And now we need that key from earlier. And I've probably made a mistake, yep. This is TypeScript, so it found it for me. And at this point, this is a valid response request, but we only care about that notes output. So I'm going to feed that in there. And for time, I've set up down here, this is going to return a particular structure. And I'm just going to remap that to what I need to power the UI. So we get back some timestamp structure, which I convert to seconds using some utility functions, pass through the frequency as it comes in, and also map it to a MIDI pitch for the UI element. So if I just call that here and pass it the response, that's going to come out how we want. So if I just refresh this now, open up a file. This takes a little bit of time to extract, so whilst it's doing it, I can play the original. Someone singing happy birthday. We don't get a progress bar like in the previous example because we're just using something that just gives us everything back when it's done. No progress information in between. So if we start again, there's now a synth playing the same thing alongside it. And we don't need to listen to that any further. So just to wrap up, I've talked about building cross-platform audio analysis apps with web technologies. I've talked about a set of tools for bringing existing work to the browser. Actually, the latest version of Sonic Visualizer 3 does all of its extraction through a Piper server and client now, which allows us to take the VAMP plugins out of process so that we have a more reliable host. If a plugin crashes, it doesn't bring down the host, and it allows us to host 32-bit plugins in a 64-bit host on Windows. And also now sets us up with a nice boundary where we can now communicate to other servers. So you could have a local node server with extractors you've written in JavaScript, which is the opposite of what I'm talking about here. I prototyped an app that brings some of this stuff together with libraries from the community for visualizing, and gave a quick tour of how you might make something similar. You can visit our GitHub organization for the source code for all of this and some docs. And cheers for listening. Any questions?
Thanks to be in time, I was ready to ring this. Okay, questions?
That's what I like.
So now you've mainly used like already existing sound files. Does it also work with real-time audio?
No, so I mean, at this point, as I said, one of the motivations was for bringing a lot of these existing extractors to the browser. And these VAMP plugins as they are, a lot of these algorithms are offline. They do their work offline. Some of them don't, but the more interesting ones that label chords and stuff like that, or do that transcription, are offline work.
Yeah.
So it depends. The answer is it depends.
Okay, thank you.
Right. So it was a bit unclear for me. So the extractors in the demo that you showed us, were they running in a web worker or on a server somewhere?
So the server here is in a web worker. So the
Right.
term server is a bit
Right.
is a bit weighted, I guess. But
Okay, so
yeah,
it's not a network.
all the
call.
extraction's happening in the client. It's just happening in the worker because otherwise you're going to block your UI.
Right. So and the secondary question is that can we use those workers separately than the framework you've built?
Yeah.
Just as extractors, and are they somewhere available?
Yeah, so I mean, the thing I'm providing really is for doing the extraction. I've used other stuff in an app to visualize them. But yeah, the extractors themselves, we've compiled a bunch of useful ones from these VAMP plugins. And so that PN one is published on NPM wrap, so that it's automatically going to run in the worker. And I'm going to do that with some other ones. But yeah, you can check out this.
So we don't need to use Piper to use the extractors?
No, you do. That's how
Oh,
you
have
use
to.
the
Okay.
extractors.
Okay, cool. Cheers.
Any other question?
Just a quick one. Is this restricted to audio data? Or can you apply the extractors when there comes a data?
I guess you that too. I don't know what the output would mean for a lot of them.
We've got time for another question, I think.
It's fine. I'm leaving.
Okay. I've got one question. Is the language you used was sort of Python on the left?
No, that's a language called TypeScript, which is
It's TypeScript, okay.
JavaScript with static types in your development environment.
So,
and compile.
but
all
I
that
guess
goes
it's
away
usable
across-
from plain JavaScript too, or?
It's in JavaScript. I mean, you can install that
Yeah.
library and just write it in JavaScript. The fact I wrote it in TypeScript and was writing in TypeScript there, it doesn't matter.
Okay, so thanks for this presentation. So the next speaker.
Ooh, hello. That's better.
Right. Okay, Nicolas from Birmingham City University. We're waiting for your presentation. I don't have a paper with the program, so I need to read what's
there you go.
on the slides. So we're talking about an audio plugin framework, and I suggest that you talk with me and other people at the conference who started thinking about a web audio plugin framework too.
I was planning to ambush you at lunch armed with sandwiches to get some
Yeah,
feedback off
okay.
you, but I'm sure I'll grab you later.
Okay, so go on.
So yeah, hi. So I'm Nick. I'm been building this intelligent plugin framework for about a year and a half or so now. And hopefully there's some people in this room that are using it, but I'm going to show you what we can do with it today. So thankfully I'm most used to starting the world for this room, but as we all know, with the Web Audio API, it's a fantastic and easy to use system with loads of nodes predefined, and it can do some amazing, amazing things. I mean, even in just the 3 years that this conference has been going, the kind of stuff that crops up is just absolutely phenomenal. But we're now getting to a stage where we want to do some even more and more amazing things. So we want to be able to build some distinct processes. We want to be able to replicate these and instantiate these many times. And we want them to be sensible to use. So, we were talking earlier about, a guitar, a guitar system or guitar amplifier has predefined controls and things. So we want these things to work. We want them to make intelligent decisions, perhaps, to manipulate parameters on their own, and to support any user interface. So the problem is that the Web Audio API is a very, very low-level thing here. It holds a limited subset of audio processors. These have certain parameters which may or may not map to what you do. There's not really a very common framework, and I know I always like saying I'm throwing yet another standard into the mix for people to choose, so we'll see if maybe we can agree on at least one somewhere. And all of this limits the creativity and the impact of the API as a whole with all of these systems. So several solutions have been made before. I've listed three here, but there are loads more. These allow for the creation of these new modules, people to define plugins or objects. You can have custom parameters, and the trouble with these is the integration into existing projects isn't always that clear. The host might not always know what to do, and this ends up in very hard-coded environments, which are very, very difficult to manipulate later, or may use inefficient JavaScript, such as script processor nodes being flung around a lot today as well. To do this work. So there are some problems basically on getting our ideas or processes into browsers and actually into production or into code. So we developed JSAP or JSAP or any other way you want to pronounce it. So we've been creating this with the overview of what's it like for a developer rather than what's it like for a plugin developer, what's it like for a host developer. So we basically create a wrapper to basically hold in a part of the graph, of the Web Audio graph. So and this allows us to just wrap up these little objects, but you can then replicate them really, really easily. We also put in there an audio feature extractor, another one we developed called JS Extract. And we also put in a simple messaging system to do inter-plugin communication. So we can do cross-adaptive effects, again, really, really easily. And there's also a dedicated host manager for all of this. So again, we've built this so that you can just put the host in. You don't need to worry about how plugin works or anything else. You just tie this thing into your system, and it should work fine. So here's an example. We just got lovely, simple three audio nodes put in there. Just simple audio in, gain node, wave shaper node, bipod filter, output. So many people might already know what this might be used for. This could be a tone control distortion object. So we can wrap this up in just one big object called tone control as a prototype. So instead of you having to build these three nodes in your own, you just call tone control and it'll create this object for you. So the second problem was on parameters. So these are all the parameters that get enumerated out of those three nodes. So there's 7 in there. Most of these might not make sense if we're building a distortion plugin. Wave doesn't make sense as a distortion drive. You might not want all the bipod filter controls out there. You might want to enumerate these things a bit more, or to parameterize these things a bit more. So with JSAP, we allow that. We allow you to basically map onto these things with a whole host of things. So you've got scripts, numbers, strings, or whatever else. There's quite a few different parameter versions you can do. So again, now we can build this plugin, where we can build this object which holds all of these things, just in one thing called tone control. So it removes your ability to have to build all three, map everything out, and hard code this stuff. You can just build one, which makes it quite easy. With defined ins and outs, with defined user host controls, with defined parameters, all in just one place. Okay, so that's cool. So that's what a lot of other people have done as well, and a lot of other things. But what we've done, I've sort of just said that. So 78 lines of JavaScript to do that, all just with Web Audio API framework. What we've done is we've actually done the host side as well, which we think is actually quite important to do. Because obviously most systems just talk about audio in and out, but obviously a host actually has to do a lot more. This has to do all the user interactions, all of the playback events. Plugin has to communicate back to the host in a standard way of my parameters have changed, or there's a thing I want to share, or something I want to do, or there's plugin events that happen that might be, it's loaded, I've unloaded, I've started, I've stopped. So building the host is important. But again, we don't want to make it burdensome to introduce. So that's literally all the code you need to introduce into your project to get it going. And most of that code you probably have anyway, such as start a new audio context. So we're using these things today. So in the DAW demo that I was talking earlier in the poster session, you can come and see it. So we can use these to give near desktop experiences. And on the bottom there, you can see a list of plugins. We've also used it in the SAFE project online. So some people may know the SAFE project. So we actually we refactored these codes for the online system. So you can go use these. They're open source. Go get them. They're everywhere. And I can give you, I love last minute demos. I can give you a quick demo of one. So very simple game, but we can do, I can go get that tone clip. So we can do that, or we can do something a bit more fun, a spectral wah-wah system. So this just takes a spectral centroid and applies a wah-wah pedal effect to it, for instance. So these are all things that you can just do inside JS Extract. JS Extract right now. Hopefully, I think. Can I go back? Yeah, it can. So thank you very much. There will be a tutorial on how to do all of this, both building a host plugin, integrating to the host and building the plugin on Wednesday at 2 o'clock. So do come and get it. All the slides are going to be on our page and will be given there. So thank you very, very much. And any questions?
Thanks, Nicolas. You finished in advance. That's not bad. Any questions? Okay, I've got one.
Yes.
Okay. Do you think we need a difference between instrument plugins and audio processing plugins like the VST and the VSTi? And do you think also that we must think already to the MIDI control of these plugins?
Yeah, definitely. So right now, JSAP requires an audio input-output because we started it on a feature chain. However, there is a project here, which is the RT-SFX, so Aidan and Thomas around here, at the back up there. They've been using these, so they've been using this for taking synthesizers, so just simple parameter inputs to generate audio as well. But yeah, definitely we need to also have a way of doing MIDI controls or at least some sort of time event control system. So it's important to have the standard, I think, as well to do that. But yeah, they definitely need to be together, or at least both well defined to interact well with each other. Just that sort of.
Any other question? The guy who wrote the modular scenes we talked on the Slack Web Audio channel is not here. It's a shame because he wrote a document already about many ideas related to plugins for Web Audio 2. And he distinguished the plugins that are in a window, the plugins that are not graphic, the plugin that will be draggable, and so on. So he proposed also to specify if the plugin has a GUI and what sort of GUI and so on. So the topic is wide, and I really think we need to sit down somewhere.
Definitely.
But also with people from the Web Audio core group, maybe.
Yeah. So definitely in this one we have a GUI handler, so you can define multiple GUIs for each plugin. You can just call them up based on what size of the screen it's going to have. But ultimately, they will enumerate out their parameters. So if a GUI can't be made, then our standard says the host then has to provide a sensible one. So in these JSAT, in the example one here and here, these are all just auto-generated as of when they're needed. So we can enumerate out a whole load of plugins. That's the reason why I mute that. So yeah, it's important to have user interaction. It's definitely very, very important to define. Yep.
Any question? Surprised this topic is not raising more interest in the room. Yeah.
Hey, thanks. This looks really interesting. I was just wondering, are you aware of any examples of plugins written in another language being compiled to this format?
I'm not aware of anyone who's done that directly. I mean, our system is basically just a wrapper. So in theory, anything can work. I mean, we've even put JSAP nodes inside JSAP nodes, for instance. So it just sort of holds that subgraph. So as long as an audio graph can be made with a defined input and output point, it'll work. You don't have to define parameters. As we saw with the spectral WAV, there is no parameter for that. It just does its thing. You have no control over it. So yeah, so as long as that subgraph can be defined, it will work with pretty much anything. So we're not sort of creating a limit at the same time saying you have to use a script processor node. You can do what you want in there. Okay.
Okay, I think we will go on. Thanks a lot, Nicolas, for this talk. The next speaker is, okay, it's Matt. It's good when we meet familiar people.
This mic here, is this a mic?
It is.
Yeah, you can use that.
It's been really
can use it.
annoying me. Can you turn it off?
Both are on, yeah, it's a good idea
Yeah.
to turn it on.
Is that, yay!
Oh,
Yeah.
So Matt, will you perform also in the evening? Will you perform in the evening this time?
I'm performing on Wednesday.
On Wednesday, yes.
And I've got a demo this afternoon.
Okay, so Matt will be on the demo session and he will perform on Wednesday evening too. And I will present, I think, again Loop.js, next improvements, or yeah, because I don't have the program in front of my eyes.
Well, sorry, did you ask a question?
Yeah, no, I said, will you present again about Loop.js, the next
today.
improvements?
Oh, is this the HDMI cable?
Yeah.
Which one?
I think that's. Would you like it? It's actually better if you use.
Oh, yeah, I'll try. Sorry, I'm technical.
I didn't find a way to turn this on.
So it just turns back on again?
So you'll guess if web audio is ready for the dance floor.
Time you're pressing. But I think it's fine if you just. There's some. It's fine.
Looking good, I think. Okay. Oh no, I've got it. I've got it.
You got
it. All right, technical problems solved. It's a tech conference, so you've got to have technical problems to really make it on topic. I'm going to ask the question today: is web audio ready for the dance floor? What do I mean? Well, I'm going to try and answer the question, I guess. But what do I mean by that? I mean, we can make these great demos that show off these amazing features that kind of look like little pieces of audio software we've seen in the past. But is this API ready for running for like an hour at a time or more, or dynamically swapping and loading things out and real-time performance on stage, where if it glitches, the entire crowd is going to be very disappointed or laugh or something like that. And I have made such an app, regardless of whether I should. And so I thought today I might share some of my exciting experiences that I've encountered over the last few years. So I first demoed this last year at Web Audio Conference. And since then, I've been working really hard on solving a lot of issues. So if I'd given this talk last year, I definitely would have said, don't even bother, it's a waste of time. No, you've got to work really hard. That's going to be the key takeaway from this. Anyway, so this is a screenshot of Loop Drop. It's completely web audio based DAW, but it's not like your traditional DAW where you have tracks and timelines and recording. It's actually for completely improvised live looping type music performance. So the reason I actually made this in the first place was because I couldn't find any software that quite worked the way I wanted to. I tried messing around with things like Macs and other platforms, but I just really wanted to write some code, and I knew JavaScript already, and I knew the web, or at least I thought I knew JavaScript and the web. And then there was this amazing new API called Web Audio API. I thought I had to totally give this a go. So I'm not going to tell you too much about how the app actually works because I'm going to be giving a demo this afternoon. I'm also going to be performing with it. So instead I'm just going to dive straight into... this is a video of one of the first times I ever used Loop Drop live in front of an audience. And hopefully I actually have sound. I never checked. Oh dear. Is it running out the VGA? Or no, I didn't plug it in. Yeah. Good thing I didn't embarrass myself. Yeah, okay, yeah. So everything was going great. The crowd were really into it. Oh yeah, little glitch. Oh. You can see the crowd, how each time it happened, they were dancing less because I was betraying them. Every time there was a glitch, it was like their heart would jolt. You know, there was a few people that didn't care; they were still dancing. But there was like the key people in the audience, and the worst part is for me as the performer, it really threw me out. So, if you were building an application that's going to be like real-time serving a crowd and with a huge sound system in the paddock, like in the case of this. You sort of can't have that happen, and like luckily they're a forgiving crowd, and it was raining, so it was the least of the problems. So what happened there? What was the glitch that caused all that to fail? And the answer is, I have no idea. I have no idea what caused that to fail, and that's because web audio is a black box. You have no idea what the actual web audio process is doing or how it's doing it, except that it's using CPU. And you don't even know if it's your browser that's using the CPU or the web audio process specifically, because all you've got is your main master CPU output. So it's really nice that web audio is isolated from JavaScript in this way, because it means that typical JavaScript type issues won't actually stop the audio samples from playing. So in the case there where you heard a complete audio dropout, that wasn't JavaScript's fault. That was simply probably CPU just getting too high. And that could have been because I was creating too many audio nodes, or maybe my computer just suddenly decided to start doing some background task, who knows, but something just pushed it over that limit. But the thing is, I have no idea what it was. And this is just sort of like one of the key frustrations that I've had, and the way I've worked around this is just making sure that I'm trying to keep absolute control of everything that happens, making sure that there are no just dangling nodes. I clean up everything that I know is never going to be used again, and really just, I mean, this is something that I'm still trying to solve today, and I've been working on this for 3 years, and I've learned so much. It's very hard for me to give it any kind of talk. Like I could give a talk just about this kind of thing, but so in this talk I'm just going to gloss over stuff and basically rant about how terrible everything is and how much better it could be. But so here's my suggestions of how we could make this situation a bit better. If we could just get some insight into what is actually using your CPU, we could start taking control of some of these runaway CPU issues, like especially when you're learning, you don't necessarily know what types of nodes are going to be CPU intensive, and if you could just see, oh, that convolute, like, I mean, it kind of makes sense that reverb is going to be expensive, but it's not obvious to a new person developing, and they might not realize that it's that reverb that they added that's actually causing the entire thing to completely crackle and give up. So if we could just get some stats on this stuff, like a flame graph of like what all the different nodes are doing, I would be so happy, and I could have probably saved at least 100 hours. But like I said before, JavaScript doesn't get in the way of actual audio playback, but it can get in the way of telling the Web Audio API what it's going to do next. So in an app where you have the next minute or so planned out, you know exactly what's going to play, you can tell the Web Audio, here's everything that's going to play for the next minute, and it's going to play perfectly timed. There'll be no dropouts or anything apart from the CPU issues. And you could just block your entire thread. You could have all the fancy CSS animations you wanted, and nothing would glitch in your actual Web Audio code. But in my case, I'm more like laying down the tracks as my train is going, because I'm doing real time. I don't know what's going to be playing a few milliseconds before it happens, because at any moment I could be changing the loop, or I could be putting some new instrument or whatever, and so I can't schedule this whole minute out ahead. Instead, I have to schedule, maybe 20 to 50 milliseconds in advance. So that means that if anything in JavaScript happens in that frame that takes longer than 50 milliseconds, that's actually going to push my scheduling out, so that kick drum will never fire. And how did I work around this? Well, I haven't really figured it out, but really all I'm doing is I'm just not doing any garbage collection whatsoever, if I can avoid it. So there's obviously some, because JavaScript is really hard to write in a way that doesn't cause garbage to be generated, and I still want to use some kind of nice high-level abstractions, and I don't want to have to write all my own weird stuff. So there's definitely some going on, but I've just tried to really optimize for the things that cause the spectacular, catastrophic 200 millisecond garbage collection stuff, like the full mark sweep. You just don't want that to happen. And one of the key ways I've handled that is actually keeping the heap size right down. That seems to really help. I don't know. This is all superstition, really, because there are some great dev tools for debugging this stuff, but it's when you've got thousands of audio nodes, it's really hard to figure out what's going on. And of course, yeah, if you have a user interface, you want it to be as minimal as possible. You don't want it to be using any CPU. But the situation could be better if somehow we could be running our web audio stuff, our scheduling, and specifically our scheduling, and maybe the connection to your MIDI devices actually in a separate thread. So that would mean that your interaction, your user interface, or your fancy virtual DOM and all that kind of stuff isn't going to be interfering with your audio scheduling. There might be some clever hacks that can be done around actually quantizing the garbage collection to, that'd be the other way, is actually having like a request audio frame where you say, I want to get like increments of like this amount of time, and if it goes like, sorry, I'm running out of time, so I'm not going to talk about that. And there's just stuff that web audio can't do, and that's a real frustration. And there's actually a lot of things you can do with crazy hacks, but the problem is the crazy hacks use way more CPU than you expect they will. So, for instance, I was doing a lot of stuff with like transforming data from like a modulator, like an LFO that's been controlled from a MIDI controller that's actually modulating like the overall pitch that's been quantized to a scale. And that's like a lot of transformations. And if I did that as audio, and I had it running on all of my synths, which I could have like, 50 channels are running at once, that's a lot of CPU overhead. And so what I had to do instead was kind of shim the audio nodes using some pseudo audio param stuff. It doesn't really work perfectly, but it kind of works well enough. And then the CPU is right down here. So but that's the kind of stuff you got to handle. And yeah, audio worklets, woohoo.
Could you go back to your previous slide?
Yes, sure. So I'm trying to finish. Cool. And I'm sure all the stuff's going to get better in the future, but for now, what I suggest is using some kind of library where someone's really caring about trying to keep the cross-browser stuff, so you don't have to work on that yourself, or you use Electron. And it might seem weird, like why on earth would you be building a native application in web audio when there's all these other tools? But if you have my background, where you've actually done web development before, and you want to write JavaScript, and you want to make your own music software, I totally recommend just making a desktop application with web audio. It's totally great. And yeah, the only way we can solve this is just to wait, I think. And that is everything I have to share for now, but I'll see you the demos a little bit later on. Thanks.
Thanks, Matt, for the presentation and for pointing out that we really need good debugging tools that do not break. All my applications recently break the debuggers, the web audio dev tool, the web audio extensions. So, okay, any question?
Not exactly a question, but just to point out that the stuff with script processor node that you and everyone else is falling over with at the moment, some of that should go away because audio workers will replace that with the off-the-rate main thread, and so some of that will help.
Yeah, it'll be great to be able to do that.
Once people implement it, of course.
Oh yeah, for sure.
In your own time, browser vendors.
Yeah. The spec's looking great.
Okay, but recently I talked with Raymond Toy from Chrome that said that audio worklet could be abused, so they reduced all the priority of the threads. And it started crackling, and when I run several web audio applications, I've got glitches that I never had before. So maybe it's a temporary problem, but...
So yeah, in regards to what you were saying, I'm not using any script processor nodes for that very reason, except for a bit crusher. Well, it's not a bit crusher, so it's a desampler. But actually, the weird artifacts add to it. As long as you put a convolution reverb after it, and then it kind of makes up for the dropouts. But yeah, so what I'm talking about when I'm talking about the dropouts is actually just because I'm having to be scheduling things milliseconds before they play. Right. Yeah. Any other questions? Or things you want to yell at me about? You should be more positive.
Hey, very cool. I'm just curious about Electron. Is there any other benefits you're seeing from Electron, or is it just the fact that it guarantees a stable API with web audio?
Well, that's a key one. The other one is it makes things like streaming large files from disk really, really easy. Well, a lot easier. And you can potentially run multiple processes that post messages between each other. So that thing I was talking about, where it'd be really nice to be able to run it in a separate process, I could probably do that in Electron. But I'd have to rewrite so much stuff, so I haven't actually tried that yet.
Cool, thanks.
So Soundtrap guy, how do you debug? Do you have internal tools, or do you rely on the dev tools?
We're relying on the dev tools.
Okay.
And Chrome source code.
Okay, so we're in the same boat. Another question?
Are these types of problems all things that will disappear, you know, in the future? So, like the history of DAWs has been that there were a lot of problems that were limitations, and then at some point they kind of disappeared, and we stopped talking about how many tracks your CPU could handle for native apps. Do you see the development of the web audio API and computing solving the problems you described here as native applications have seen that happen? So you're saying that nothing changes in the browsers, but the computers themselves change over the next 10 years. So if we ran loop drop this exact version in a computer from 10 years from now, would all these problems be gone? Not exactly like that. Are you talking about more of like an interplay between the two? Well, it's like how often do you go past your frame budget? Right. Like so if everything takes literally 1/100th of the amount of time that it took, might you have like less than 1/100th of as many dropouts? Like might you have 0? Yeah, okay, so that would apply to some issues. You're talking about things, so basically CPU-bound things. So if it's a CPU-bound glitch, then yes, so the garbage collection would get shorter. I'd be able to render more nodes at the time. But the garbage collection problem still wouldn't fully go away because it's all about beat frequencies, kind of. So if the garbage collection is triggering at the time when I want to schedule things, and then something else just happens to kind of line up with that, but sure, the probability of that happening would reduce greatly. Thank you. I think.
Okay, I don't think we have time for another question, so I will ask the next presenter to come. Thanks a lot, Matt.
Thanks.
I encourage everybody to try loop drop. I show that to my students to explain Electron.
No. Yeah, I know, it's just
Yeah,
twisted.
okay.
It's twisted.
Do you have sound?
No.
No. Okay. So I'll just leave it.
Might not even have video.
Let's see if it is.
Okay, next speaker is Astrid, I think.
Yeah.
Yeah.
Do I need this?
Okay.
All right.
So talking about an IDE for embedded systems using web technologies. Okay.
Originally, my colleague Liam was supposed to make this presentation, and I found out about 3 hours ago that I was doing it, so the ink is hardly even dry on these slides. I have no idea how long it is or what I'm going to say, so come with me on this adventure. I'm not going to be talking about the audio API. I'm actually talking about how we use web technologies to make an IDE for an embedded system. And that embedded system, it's an ultra-low latency system for audio and sensor processing. It's called Bella. The Augmented Instruments Lab is a research group here in C4DM at Queen Mary, and myself, Liam, and Andrew are the three of the original developers of Bella, and the Bella came directly out of that research over the last, I guess, 3 years. So this is Bella. It's a little board which is really for making instruments and effects boxes, stuff like that. And it is something that you can plug in, do sensor processing really fast, other than Arduino, because Arduino tends to be quite slow, and other comparable embedded systems don't have the low latency capabilities that are really necessary for low latency action to sound. And that is where Bella comes in. Now, when we were looking at it, we thought, well, actually, see, every slide's a surprise. So this one is just like briefly explaining how Bella works. If you want to know more, ask me afterwards. But basically what it is, a little Linux system, and using a library called Xenomai, it pushes all system processes to a lower priority than audio processes, which is how we achieve this extremely low latency. Most systems achieve latency of maybe 10 to 15 milliseconds. Analog in to analog out on Bella is 100 microseconds, and analog in to audio out is sub 1 millisecond. So it's a lot faster than other things available on the market. And this is how it works, really, is with Xenomai. So when I'm the design lead on Bella, and I remember thinking at the time, like, how can we make embedded programming less awful? And I was thinking about this today, and I was like, was that really my point? Maybe not. Maybe what I should say is, how can we make embedded programming delightful for everyone? And that really has been kind of what we've been doing with Bella, is trying to address this problem of usability and IDE functionality for this sort of programming. Now, everyone knows and loves the Arduino. The Arduino's great, has massive market penetration. Everyone knows about it. Kids use it, fantastic. And it's great. There's so many good things about it, but there's still some really annoying things, such as the IDE is simple, but it's simple to a fault. It's great in its constraint, but the constraint gets in the way once you get above a certain level. It also has the worst error reporting of anything ever. And the docs are not well integrated. It's hard to find things. You got to go to the forum. It's annoying. And also, pros hate it. Everyone that does anything with embedded stuff that is at any level of competency is just like, later for that, our IDE. So this is what we were trying to get at, is how do we improve usability for these kinds of IDEs? And pros want easily accessible documentation that's useful, customizable layout, being able to like move things aside. System status, like good error reporting, console output, to be able to focus on code and find a way to solve a problem fast. You don't need to have to be taught what to do, you just need to find answers to the problems you have. But pro IDEs usually kind of look like this. And I think that probably, this is a secret, but I'll tell you, the guiding principle for me in my design of the Bella IDE has been, don't make it Eclipse. And so this is I know someone might want to have a fist fight on the way out. It's fine. You can love Eclipse. I don't love Eclipse. Now, this is kind of, we always think, oh, well, if you want to do something like that's really cool that's really powerful, then it has to be super complicated. And I don't subscribe to that idea. So this was our goal, to make an IDE that's easy to use, useful and enjoyable, both when you're starting out and when you get good at it. And this is usually the gap between something like great when you're starting out, when you get good at it, you're like, so annoying. Or something like Eclipse, where you're like, it's great when you're an ultra expert and you really know what you're doing. When you're starting out, it's horrible. So we're trying to bridge that gap, because also embedded programming is already difficult to learn. It's already hard to get started with. Audio programming adds an extra layer on top of that. So we're trying to kind of encourage people to get into it, make it learnable, but also not take away the functionality that people need. So what we did was put Node on the board. And what that Node server does is it acts as kind of a membrane between the Bella core and the browser IDE. And so it is basically all information gets passed over Node. And this allowed us to do so many things. Now, I'm not going to go into it all here. I know it's a web audio conference, and I'm like really skating over this part. If you want to know, ask me. But this had so many advantages, and putting web technologies at the core of what Bella's usability is was really, really key for us. And I'm just going to outline some of these, but the flexibility of layout was totally key. This is our current IDE. It's old. It's like a year old. We haven't implemented the new one. But we were able to move things around. So this is like a tab layout that's got all kinds of stuff in it. It's really well organized, and when you don't want it, you can get it out of the way. So you don't have to look at it, you don't have to see it. But it does have really well organized information. It allowed us to like organize things in a way that we found logical and be able to adjust that organization in response to user feedback. There's also the coding, the actual code window. That runs on the ACE editor, which was originally a Mozilla project. I don't know who's in charge of it now. But that does all the syntax checking and everything else. And the console, which in this example is blank, but you get really, really good error reporting out of the console. And you can also, the console is also interactive. And probably the biggest and subtlest feature of this IDE was we moved all the tabs to the middle, all the functionality tools to the middle, which means you don't always have to drag your mouse up to the top of the screen when nothing's happening. And so we're able to it was this kind of thing and these sort of like small things that we could iterate really quickly and easily using HTML, CSS, and JS that made this really powerful and super useful. This is a sneak preview. This is the new IDE. So good looking. Not out yet. Give me 6 months. Now, the other thing that we're doing is creating resources that people can use. And we are going, well, okay, we got this web technology, there's a lot of stuff we can do with this. What can we use it for? And one of my pet peeves is having to look up a pin diagram for tons of stupid little pins, some of which shut down the whole system, and you got to count up, hate that, print out things, such a pain. So I made this, which is an interactive pin diagram that has a picture of the board with every single pin highlighted. And when you mouse over it, it tells you what it does and tells you how to call it. Ooh! And that's in those tabs. Super useful, but without something like, and it's made with Raphael and paper, I can't remember, but it's a couple of JavaScript libraries, and that's so useful, it saves so much time. And so this is the kind of powerful functionality we can bring into this IDE because we're using web technologies. The other thing that that Liam built, which is probably the biggest step up to my productivity ever, is an in-browser oscilloscope. And what this does is visualizes all of the Bella Core output up to 8 channels, but I think you can hack it to do more, in real time on a canvas element. It's so good because oscilloscopes are expensive and heavy, and nobody ever wants to go through the pain in the butt of hooking it up because you usually do it wrong. So this is just in the browser. You hit the scope button and it launches this, and there you go. There's your output. Magic. So that kind of thing has been really, really powerful and is absolutely, especially for beginners, totally indispensable for learning what the system does and how to interact with it and getting a handle on what the data is actually doing. And fast iteration has also been super, super important. This was the first, actually this is the second version of the IDE that me and Liam made under duress. This was for, I don't know, we had like 6 months. It's horrible. And then, up to the present day where we've got something that looks like grown-ups made it. So being able to iterate, but the structure of it hasn't really changed that much, but we're able to basically validate our own hunches based on user feedback. We do tons of workshops. There's one in actually audio mostly later on this week, I think. And we do them all over the world. And this has been really great to get user feedback and people going, oh, I can't find this thing, and being able to respond to that and just change the IDE. It's been fabulous. And finally, usability. And I think that usability is very much overlooked in the embed. 1 minute? I just made them today.
Yeah, you have some extra ones.
It's okay, I'm wrapping up. This is the last few slides. Get the hook. The usability has been really the biggest step up, and I think it's something that is overlooked in the embedded audio space. And that's different. So the usability advantages are that by putting this on using web technologies, having a node server on the board, that means it becomes plug and play. You just go to a URL and it loads. The IDE is there. Everything's there. The documentation, all the tools, the oscilloscope, everything you need. There's nothing to download, install. It's just on the board. Plug it in. Magic. And everyone knows how to use a browser and what to expect from it. And this, I think, is really key, is that as we go along with, everybody using web technologies every day, then you can be assured that people have a certain amount, even super, super beginners, have a certain amount of facility and understanding of what the interface is supposed to do. And I think this is the most powerful part of using this, is the user expectations and being able to know that people understand what a button is or understand what tabs are. And also we can respond to user feedback due to the speed of iteration. And expert features like system controls are all still available through and what does that even mean? Expert features like system controls are still available, though the interface is accessible. So even though it's easy to use for beginners, it doesn't mean that it's limited. It still has all the really good stuff that people who are very, very good at this will want to use. And final kind of things is that the biggest advantage we've found of basing the IDE on the web technologies is that people are already experts in using the web. And being able to leverage that meant that there could be a lot of usability problems solved right out of the box. JS is really powerful when properly applied. And we actually don't use any kind of, we don't use React or Angular or anything to handle the IDE. It's a custom rolled MVC that's quite minimal. And because it's accessible doesn't mean it has to be limited. And just because something is easy to use for beginners doesn't mean that it has to be useless for experts. And thanks, that's it.
Thanks a lot. Any question?
Hi, thanks for a very, very energetic talk. And yeah, I remember using Bella when I was a student here, back before it was called Bella. We just called it Andrew McPherson's magic musical hat. I was just wondering, so have you done any experiments perhaps with using a browser integration a bit more? So perhaps using it as almost like a local processor. So, you could send audio over the virtual network interface to the board and then audio back, because you've got audio back already for the oscilloscope, haven't you?
Right.
So is there any way of using it as a massive offloader of work?
Potentially. Yeah, that's actually a really nice idea. All our code is on GitHub if you'd like to fork and contribute.
Well,
but yeah, that's a great idea. And that is the other thing that, as a web API, the web audio API becomes more powerful, then doing things like that becomes like being able to test things before, applying filters, being able to see what that does before actually programming it. Yeah, would be amazing.
And then the final one, I'm guessing that the compiler is all done still on the BeagleBone, on the board.
Yeah.
And it's just returning whatever the compiler spat out, whether it was yes or no.
Exactly.
Okay. Yeah, good. Thank you.
Any other question?
So from the looks of it, this was a BeagleBone computer?
Yeah.
What kind of audio throughput are you getting with this? Like how many channels or whatever?
It has stereo in and out, but there's a multi-channel extension hardware coming out for Bella. Maybe it's out already, I don't know. We had a student here from another university who was working on the multi-channel version. So that is coming, yeah. I think it's up to, I can't remember if it's 8 or 16. It's terrible. I I've been writing my PhD. I've not been around much.
Another question?
Hi, Francisco from Goldsmiths. What's your, do you have any heuristic for balancing the visibility of more oriented beginner features against more experienced user features or expert user features?
I'm not sure that there's any, if there is a maybe somebody's written a Chi paper that explains exactly this. This is like a specific interest of mine as an interface designer, is how you bridge this gap between beginner and expert, because I think that field is wide open right now. And there's not a lot of bridges that are in place and not a lot of established ways of doing things. And there's somebody who has this set of heuristics, I think it's 5, can't remember who it is, but ask me later, I've got the paper, which is how do you know that people are using things successfully? And one of them is they get frustrated. You hear them getting frustrated, or they do the wrong thing over and over again. And there's they seem like really simple heuristics, but they definitely apply to experts as much as they apply to beginners. Because I think experts get more annoyed and loud when something's frustrating than beginners do, because they don't expect to be frustrated. And I found those heuristics very useful, especially in observing in our workshops. We do so many workshops that we've been lucky enough to have the opportunity to observe loads of people using this, and at a whole range of ability levels. But if you're interested, I can give you that later.
I've got one question. I'm not at all in embedded systems, but can we run web audio code on your card in a way?
I would be very interested to try.
Okay.
I don't know. I don't think so, but it does a whole bunch of. You can do PD and Faust and a whole bunch of things, but
I know
I'm
that
not sure
on ARM cards they run Linux with browsers and so on Chrome bits computers too. So this is maybe too cheap to run a browser or.
You mean like run a browser on the board?
Yeah, yeah.
That's kind of why we offloaded all of the GUI into the browser on the local computers, so we didn't have to do that, because then we could free up resources for the latency audio processors.
It's really lightweight hardware.
Mm-hmm.
I mean, okay. Okay, so thanks a lot. Do we have another presenter? Yes, I think. No, it's finished. No. Yeah, we do have one. No. I don't have the program, so.
Oh, yes, we have another presenter.
Yeah, okay, sorry.
So we have EGs the best as possible. Okay, sure.
So, Ben Woods from Berkeley College University, College of Music.
Yeah. And then the microphone. Okay. Just sounds like that's working. Is that somewhat audible? Maybe this will help. Yes, okay. Whoop. Something like that. Okay. Cool. Yes, so I'm Ben Hogue, and I'm from Berklee College of Music, and it's great to be back at the Web Audio Conference. This is my third one, so nice to see some familiar faces and some new faces. Yes, so I teach in the Electronic Production and Design Department at Berklee College of Music, and have previously was working in the video game industry. And so I'm going to be talking about web audio in the dining room. This is a project that brings together two of my long-standing threads in my work. So I've been doing web audio pieces that involve treating audience member mobile devices as sort of a crowd diffused speaker array, and I had performances at the last two events for people who were there. Setting of a Greek poem by Constantine Cavafy, The Tomb of the Grammarian Lysias, where I was singing and then audience mobile devices were providing the accompaniment. And then last year I presented a piece called Ornithological blog poem, which is pictured here. That's a screen grab from the live stream from last year, so a little Georgia Tech product placement. And that was a piece that was also for not just single solo voice, but also for choir and audience mobile devices. And so I was coordinating what the choir members, members of the Georgia Tech choir, were reading on screens. So coordinating the score as well as what was happening on audience mobile devices, which was processed voices of the choir members. In parallel, so I don't think I need to explain the web audio side of things because I think people are familiar with that, but I've also been doing this project since 2010, collaborating with chefs to create multisensory dining experiences. And that's maybe a slightly stranger one that needs a little bit more explanation. But I've been working with people like Jason Bond in the Boston area, Bondier restaurant, where I'm based. Joseph Youssef is based here in London. He has an outfit called Kitchen Theory, and we're going to be collaborating on a performance at tonight's concert, so don't miss it. And don't be too full when you come, although don't come too hungry. And did a project with Borough Market that was presented at the Oxford Symposium on Food and Cookery last month. And that was the first time I presented a couple of music projects or food projects at music conferences, but this was the first time I had presented a music project at a food conference. And I have to say, they have better food. Also working with ensembles such as Zeitgeist, St. Paul, Minnesota-based new music ensemble, and did a project last January with the Boston Symphony Orchestra that I'll share a little bit later on. So the sort of point of departure for the idea was to think about, we have all these art forms that involve combining music with ballet, with video games, with film, with theater, but we don't really have an art form that combines music with food. And started to wonder, why not? Because there's a lot that can be done there, not just to sort of accompany something, but even to comment on it and sort of transform it in some way. Think of the way that you can watch the same clip of a film, but hear it with different music and the mood is sort of transformed. So I thought that there was a lot of interesting potential there to create a kind of music and gustatory counterpoint. So I started thinking of the meal as a time-based experience. And there are a couple of ways that you can sort of break it down. At maybe the highest level, you can think of each course as being sort of similar to a movement in a symphony or a chamber piece. And then within each dish, you've got this sort of changes that unfold, the sort of entropy of each course as cold things come to room temperature, frozen things melt, flavors blend, etc. There's also the rhythm of each bite, which sort of gives you a window onto that slowly evolving dish. And then you've got the morphology of taste within on the palate, which is sort of analogous. The area where we maybe think of that most is in the finish of a wine or something like that. And of course, there's also a psychological transformation that happens even if you have the same stimulus multiple times. Your perception of it changes just by virtue of the repetition. So predicated on the idea of a meal as a time-based experience, but the challenge there is that the timings are indeterminate. It's not like a film where you can line up all your hit points and compose music to match. And so this is where my background in the video game industry came in handy. So I framed it as a technological challenge. I thought maybe this is the reason why we don't have an art form that involves food and music, is because it's actually, all right, it's a hard thing to get them in sync. So my approach was to borrow techniques from the field of video game music to develop sonic textures that can continue indefinitely and change in response to unpredictable events, while coordinating several layers of music in harmony and rhythm with real-time control over sort of generative musical textures, different musical parameters that would enable me to score the emergent events of everyday life. And so there were, whoa, never mind. That's online if you want to hear it. So a couple of different approaches to synchronization. So the easiest way, if you want to synchronize music in a meal, is to constrain the behavior of diners to match the music. And that's what most, if you think of, there are places like Ultraviolet in Shanghai. Chef Paul Perret has a very immersive dining experience seats 10 people a night, and it's like 22 courses, and I was there for 6 hours, so it's a long time. And so every dish comes and everybody eats at the same time. So that's the easy way to do it. Everybody's listening to the same thing at the same time. But it doesn't really match the way that we typically eat. And one of the things that I sort of set as a challenge for myself was to take the social institution of communal dining and see how we could create a musical soundtrack to that as it exists without having to tweak it. Another solution would be to put headphones on diners, and there are examples of this. Most famously, perhaps Heston Blumenthal in Bray, England, at his restaurant The Fat Duck, very famous place, has a dish called The Sound of the Sea, where it's a seafood dish that comes with a conch shell and iPod headphones coming out, and you put those on, you listen to the sound of the sea while you consume the dish, and there are studies that show that people will rate the seafood as tasting fresher if they're listening to those sounds. So the problem with that is that it still blocks you off, it cuts you off from the people around you, so it's a potentially very poignant, immersive experience, but it doesn't quite fulfill what we go to a restaurant to do when we're interacting with people, and I don't think it scales up to like a 2-hour or 6-hour experience to be wearing headphones and isolated the whole time. So my solution is the difficult one of setting up a multi-channel speaker array so everybody gets their own speaker at each seat, and the music is all coordinated so that even if people are listening to different music accompanying different courses at the same time, it adds up to a harmonious thing. And so within that third category of sort of the distributed sound, there are sort of 3 different areas that I've explored. So the first approach was to take a max patch, have all the sound processing off to the side, very centralized, and then lots and lots and lots of speaker wire going out to all of the speakers at the table. And that was kind of a pain to set up. And so I was interested in distributing the sound on devices. So the project I did with the Boston Symphony involved everybody having their own iPad at each seat. And so that was, so I wrote a native iOS app for that and coordinated it via Socket.io server, and everything was synchronized together. But then that is expensive if you don't happen to have access to the Boston Symphony's iPads. So what we're going to experience tonight is your own mobile devices are going to create the musical accompaniment to the dining experience. And what I'm hoping to do in the future is actually something that I've seen a number of people are much farther along on this trajectory than I am, building custom devices like Raspberry Pis or things like that, or maybe a Bella, to distribute that processing. So sort of sum up, I think that this is a really interesting area to work in. There's a lot of narrative potential here, a lot of different things that you can do with this format that I think is really exciting. So we've done stuff that is a form of sensory ethnography, going out to the farms to provide the ingredients, making field recordings, interviewing the farmers, playing those sounds back alongside the meal that is made from those ingredients. So I've done a couple of events like that in Boston. Also exploring this growing field of cross-modal psychology. There's a guy at Oxford named Charles Spence who heads up the Cross-Modal Research Lab, which is doing a lot of studies. In fact, the performance tonight draws on some of this research that shows that people associate, for example, high-frequency sounds with sour tastes, low-frequency sounds with bitter tastes, and so sort of exploring that. And then also investigating other types of narrative structures, such as poetry. We did a William Carlos Williams sort of inspired event, and this Vivaldi thing that I'm going to show you on the next slide, and working with a theater group called La Fura dels Baus in Barcelona on a project next year, and along with the restaurant Mugaritz. And actually taught a class on this last summer at Berkeley, which was really fun. I'll show a quick video just to wrap things up. This is it a video? Just a little clip of what we did at, nope. Old-fashioned way. Let's skip ahead. So this is a project, we did a pre-concert dinner based on the Vivaldi Piccolo concerto that they were playing on that evening's concert. So RV 443 if you're a Baroque music enthusiast. But taking the idea of the piccolo being the highest frequency instrument in the orchestra, and drawing on some of this research that shows that sweet and sour tastes are associated with high frequencies. Yeah? Oh, it looks amazing. You should see it. Oh. Yeah, thank you. Ooh, wow. Here we go. So you can see a little bit how I'm controlling it. So I've got my own iPad that I'm using via web page to control individually each iPad in this space. So you can see that I'm changing. In a second, you'll see that I can send global parameters to everybody, or I can also say, okay, this iPad is now playing the second course, the third course, whatever. So this little drop-down menu you can see. And based on not just the Vivaldi piece, but also archival recordings of the Boston Symphony performing that piece and some other Vivaldi pieces. So it's a custom built acoustic resonator that also functions as an iPad stand. So it's just using the built-in speaker, but channeling that out. Designed by Jutta Friedrichs, the designer with whom I frequently collaborate. So anyway, more information about this project is available online. But this just provides a little bit of a sort of a background for what you're going to experience tonight. So I'll just show my last. Oh, second to last slide. This is actually Marina Abramovich. She did a piece with Pastry Chef in New York back in 2012 called Volcano Flambe that also came with iPhones. Or headphones that you could listen to. So with the goal of encouraging people to just be aware of their environment and their senses and the people around them. So thank you very much.
Thank you for this very interesting and original presentation. It seems that some researchers found new ways to get free food.
Yeah, that's right.
Okay, any question?
I'm just curious how you balance the tension between having this kind of immersive experience and the social experience of dining. It seems like that's got to be a lot of conflict between having a screen right in front of you and something projecting sound versus the idea of what you were describing as like a shared dining experience.
Yeah, that's the only event that we've done that actually had a screen. Usually it's just a speaker, and so we try to use the screen to just, we pose little questions about, to get people thinking about the way that the sound and the music went together. But that's a tricky thing, and I'm not sure that I've gotten it right in all of the projects that I've done, but I think I try to create music that is, I mean, the classic Brian Eno quote, as ignorable as it is interesting. So I hope that you can sort of tune into it and there's something cool there, but also that it doesn't deter people from having the conversation around them. And I think because the sound is so distributed, the volume can actually be quite low. It's not like you have to have like, like if you're sitting under the big speaker in the restaurant, you're doomed, you know. So it's a tricky balancing act, but I'm trying.
There was a question somewhere here. Just.
Yeah, I was just wondering about the speaker design. Is that actually focusing on the single dyna, or is there bleed to that? Is that been designed in a way
It's designed to bleed.
Oh,
I mean, so basically it accepts the fact that making it not bleed would be very hard as part of the composition. Okay. So like that's a common, you know, sort of video game technique, is that you've got multiple layers of music and they're designed to go together, whether that means synchronized to the same beat or whatever. So I think of it as different layers of music that are happening at the same time. So most of the textures are sort of generative to a certain extent, so everybody gets, I think it's kind of neat, like, you know, if you and a friend order the same dish, you don't get exactly the same dish. I mean, they're two different asparaguses, right?
Yeah.
So it's in the same way you're getting two different versions of the music, especially prepared to order.
Nice.
So yeah, it's designed with that as a feature.
Another question?
There's one. Oh, yeah. I mean, similarly, the web audio pieces that I've done here before have taken the small speaker size of people's mobile devices and used that as a feature as well, where it stops being sort of an imperfect representation of an ideal sound and becomes a sound source in and of its own right, its own sort of instrument. Anyway, yes?
What was the feedback from the punters in the restaurant? How did they feel about the experience?
Well, we didn't force this on unsuspecting diners. So these were people who knew what they were signing up for. And feedback has been very positive. Typically, we'll get a couple of some sort of balance suggestions. And actually, with the BSO event, so that's downstairs at Symphony Hall in Boston. That was 70 channels of coordinated real-time audio. And that was the one where I realized, like, I can't just be off to the side trying to mix this. There's no way. So that's why I used the iPad to be able to wander around, and I could actually adjust the volume on each table. So I think it's a step towards that direction. I mean, we get, so balance issues are probably the most common, but most people seem to think it's a pretty cool thing. And I've had some really, people just say it was a very poignant experience, and that's why I keep doing it.
Sure, but I mean, I suppose people do experience music with food, don't they? I mean, it's a very common thing to have live music in restaurants, records playing in fast food outlets, all those kind of things. But this is obviously a more bespoke experience. I mean, I've experienced the Fat Duck headphones thing, which is very poignant, actually, and the immersive element is really quite beautiful, and then you actually talk about it to your companion, so there's that kind of aspect as well. It actually increases the engagement on some levels with both the food and the sort of sonic elements.
Yeah. Yeah, I think that's, well, with the, like when I had I haven't had the Sound of the Sea in person, but I've had the Marina Abramovich dessert, and it's a cool personal experience, but it's also an impossible thing to share. You're in the middle of this, and then somebody wants a bite, and you're like, okay, and you give them the headphones. Yeah.
Any other question? Or maybe you'll talk with Ben at the coffee?
Sure. Yeah, happy. There's plenty of documentation. Audiogustatory.com. Do I have it up there? That's where I've got all the information about these projects. And so, yeah, I think that there's a lot you can do. I mean, in most of those cases, I mean, it's true, music is ubiquitous in restaurants, but almost never does it have really anything to do with what you're eating. It's just, and I'm amazed now that it's so easy for anybody to just plug in their iPod or iPhone or whatever. It's really just like, here's a song I like, and by the way, here's, every other aspect of the dining experience will be totally tailored, the design, the lighting, and all of that stuff, and then just throw in any old music. So hoping to foster an increased attention to multi-sensory experience.
Okay, thank you very much.
Thank you.
Ja, genau.